Do. So, good evening, whoever has joined, Shruti. Hope your preparation is going well. In this lecture, we will focus more on GATE DA. I will give you how to prepare actually. I think it's not a good time to tell you this, but still, never better late than never. I'll give you some tips, try to ease you, motivate you, and also help you to better handle the exam. So typically I was told to take these lectures to give a overview on Gate DA, how things are there, what is the overlap with CS lectures with the Gate CS course. I think you all have studied Gate CS by now. So what are things that are common between Gate DA and Gate CS? And to motivate you, I thought of bringing you questions from the last year Gate DA paper because those questions you will never find in Gate CS paper because they are super easy. They are very basic questions because the reason is um, they would want you to actually because Gate DA is given by other branches as well, and they do not know as much CS as you do. So to not have this problem, they kinda gave a very simple Gate DA question. So again, without further ado, let's begin. Um, Basically, I thought how to tell you to prepare is the best way is to just say the syllabus out, which is given in the Gate um, paper, and what are the things that are common and that will help you. So this is one of the most important topics for your Gate DA paper, probability and statistics. If you do not know this, then it's hard to actually uh, sit for the exam because you will understand. I've also given the weightage last year how much questions were asked from this topic. So, how good are you in probability and stats, Shruti? Not that great, no problem. Do you can you guess why there are some topics underlined here? You see, there are some topics underlined. There is some topic that is not underlined. Um, this is done because they are also in your GATE CS syllabus. Okay, in your GATE CS syllabus, you have counting, permutation, and combination. You have your probability axioms. In your engineering maths, you have sample space, events, independent events, mutually exclusive event, marginal probability, conditional probability, joint probability, Bayes theorem, conditional expectation and variance, mean, median, mode, standard deviation, correlation, covariance, random variables, discrete and continuous random variables, probability distribution function. Only you have two or three or four topics extra, which is one is t distribution, which I won't say is a very important topic for your KDA paper. Chi-square distribution also is not very important. You may skip it given the time, but you may actually not skip at all. Central limit theorem. Please do not skip this topic. It's a very important topic for your exam. Also, confidence interval. These are small topics. It won't take you more than half a day to prepare. So these are small topics. You may have been asked questions. So these four topics, I would suggest you to take half a day. That will be enough for you to prepare for it. Okay, and others are gate. Others are like if you read one, you have benefit in both the places in your gate CS as well. Okay, so again, if you still feel afraid of probability, like I always do, I always have a fear of probability. I would suggest you please maintain something called a cheat sheet. Okay, a cheat sheet, it's available on the internet as well anyway, but I would suggest you make your own where if you know there are many different probability distribution like Poisson, normal, right? Like Poisson, normal, Bernoulli, right? Each of them have their formula for the PDF probability density function. Each one of them have formula for the expectation. Sorry, the what is it called? Expectation, yeah, and variance and the standard deviation. So also uniform distribution, and there are others as well. Alpha beta distribution. There are others as well. You can see also in the syllabus they have given the probability functions that are there: Poisson, normal, standard normal, t-distribution, chi-squared, exponential, and all that uniform. So please maintain a cheat sheet where you save all the PDFs as in probability density function. For what is a probability density function for normal distribution, right? You should know 1 by root over 2 pi sigma e power minus x minus b by sigma whole square. So all these things you should know. What is the expectation? What is the formula for variance? And what is the formula for standard deviation? I mean, if you know the formula of variance, standard deviation is root over of variance, right? So if you just know variance, it should be okay to derive the standard deviation. Okay. Have you maintained any such sheet by now? Do you have this in the notes? I have the notes. Very good. So please, I would suggest you. This will take a day to. If you have the notes, please practice some questions of all the distributions that are there. Bayes theorem, I think you know. I think you know Bayes theorem. Bayes theorem. There are some questions given in PYQs. You can solve that. That will be enough for revising Bayes theorem. What is your independent events? What is mutually exclusive events? What is the basic funda? I mean, for independent event, it's like P of A intersection B is PA into PB, right? And mutually exclusive events, when are two events mutually exclusive? When the probability of occurrence of one, the other event does not occur, right? So that's what mutually exclusive event is. For example, if you pass the gate, definitely you're not failing the gate, right? These are two mutually exclusive events. So um, random variables, what are random variables? Correlation, covariance, all these are just formula. I don't think it will take more than one day to prepare. So what are the resources that you are using, Shruti? Do you want me to give you some resources on to prepare, or is it okay? Please give. Okay. So I think we have a this IGC's lectures, but if you feel those are like 2 hour long lectures, who will wait and watch? I agree to that. See, I am kind of being in the shoes of you and saying all these things, right? So I would suggest there is a person on Unacademy called Shrenik Jain. Have you heard of him, Shrenik Jain? No. So Shrenik Jain is a person. He's in Unacademy. He's in YouTube as well. He has this probability lectures, and it's very small lectures, 5-10 minutes lectures, fully gate centric, and he will also teach you how to solve problems. He actually, for me, uh, if you ask me, right, when in gate CS, when I was preparing for probability, I took till the last, like on December month, I started preparing for the math subjects. So I was very scared with probability. This guy really helped me to come out of that problem. So Shrenik Jain, please try to watch his videos. He is very good in this, and he has beautifully explained everything, all the probability, mass density functions, all everything. He has explained it beautifully. I'll just share one of his playlist on the chat. You can see this playlist just to understand how he teaches, and he is fully gate centric person. On an academy you will find more of his videos that are um, more he teaches primarily gate maths, engineering maths for the gate. Luckily you have all this as common, so he teaches this as well. So I will highly recommend you to watch these lectures. If again, if you don't have time to watch the 2 hour lectures by IGC, I absolutely understand that and I respect that. And you should not also, because now is the time to kind of learn things as soon as possible and go with solving questions, right? More the questions you solve, the better you are at. So he is one of the guys who will heavily help you. He will highly help you to ace the exam. Again, these are YouTube videos. I won't be paid at all. I don't. He doesn't even know me, but I am always thankful to him because of the help he did. Okay, so this is the probability and stats. What I can say, how you can prepare. If you follow his lectures, I think again, people have different time to capture things. People take time to learn different things. I am not a very quick learner. Learn slowly. I don't understand concepts in one go. So but if I were you, I think it wouldn't take more than 3 days to actually prepare for probability and stats in the fastest way. I would just go and refer to his lectures if I were you. Okay, you may have a different path. I respect that, and I allow you to follow that. It is just what I would do. Okay, is it clear? Okay, so this is about probability and stats. Next is linear algebra. So this is one topic which has a very less overlap with your CS syllabus, right? Very less. I mean, even though these are there in your CS syllabus, vector space, linear dependence, independence, all are there, but the questions have never been asked actually. So I don't even say they are there, right? But matrices is there, um, orthogonal matrix is there, idempotent matrix is there, eigenvalues, eigenvectors are there, determinant rank is there, right? So again, I think I have asked this question earlier as well if you have attended lectures, but there was one wake up call. Okay, so let's quickly do a linear algebra question. Okay, I hope you all know this, you have done it in your school as well. Everyone knows how to calculate inverse, right? Inverse of a matrix. Do you know? Everyone knows here, like it's simple, no? Inverse, so in school we used to do it, right? In school. So let me give you a matrix. Let's say matrix A, 1 2 3 4 5 6 7 8 9. Now what is the determinant of the inverse of the matrix? How will you solve it? Maybe you would say that the first step is to always, obviously I will calculate the inverse, right? And the second step is I will calculate the determinant of A inverse, right? Everyone agree to this, or there is some other way? This is how you would calculate, right? Or there is some other way? You would calculate the inverse and then you will calculate the determinant of the inverse. Whatever matrix you get, let's say you get some x, y, z, you will calculate the determinant of it, right? So this would take about 5 minutes. This would take about 1 minute. 6 minutes gone in this question. Can I do something better? See, that's where it comes. So determinant of A multiplied by determinant. Okay, first of all, let's not go here. What is A into A inverse? Anyone? What if you multiply A with its inverse? What will you get? What do you get when you multiply A with its inverse? You get I. Do you know this property? I is the idempotent matrix, right? So if I take the determinant on both sides, A into A inverse equal to determinant of I. What is the determinant of idempotent matrix? Just take any idempotent matrix 1 0 0 1. What is the determinant? It is 1, right? Every identity matrix, the determinant is 1. So, and this is a property. If you have two matrices A into B, if you find to try to calculate the determinant, it is nothing but determinant of A times determinant of A inverse. equal to 1. So what is the determinant of A inverse? 1 by determinant of A. So what do you have to calculate? The determinant of A. You do not even have to calculate A inverse. So you calculate the determinant of A. 1 by that will be the determinant of A inverse. Okay, this is just one small glimpse of how things you should do because time is limited. And again, if you want resources from where to study, please refer to the same person that I'm talking about in the previous slide. Okay, apart from IGC lectures, which you can always see, but if I were you, given the time, please look at lectures by Shrenik Jain. Okay? Okay, he has also taught all these things in a very fast manner. Very fast, as in he does not talk bullshit. He does not start with "Hello, we are welcome to learn," nothing like that. He straight away goes to the point, explains you things, solves questions, moves ahead. Okay, so please watch his lectures. It will be very helpful given the time you have now. How to calculate the rank of a matrix? You should know that. You should know how to calculate, how to reduce a matrix to row echelon form, right? And then just find the number of non-zero rows, that will be the rank. How to solve the system of linear equations? You must have learned the back substitution method, right? Row echelon form, and then you back substitute to get the values of the unknowns. um, Gaussian elimination, all that you can see. The thing is, all these things you can also leave, okay, if you don't have time. LU decomposition, SVD, although these are not very, sorry, these are very important topics, but given the time, if I were you, if I have not studied yet, or then maybe I would better focus on the things that I have underlined here, because if I do that, then at least my gate CS will also be saved. So please try to follow this, and if you have time, you always can learn. There is no problem in learning new things. You should learn, but I've just come here to give you some pointers on where you should learn from and who can teach you at this moment of time. Okay, so he's one person whom you can refer to his lectures. Now you might think that I have paid IGC. Why is this guy showing me lectures of a different person? See, that's not the point. Okay, feel free to watch the videos of IGC. They are very detailed, very beautifully explained. Everything is beautifully explained. Okay, but each lecture is 2 hours long. Can you sit for 2 hours long for a lecture now? Ask yourself the question, okay, and then try to look at the bigger picture. Okay, sadly we did not do any crash course yet, but maybe in the near future we'll do that. Okay. Okay, this is one of the most important topics and very small it seems, right? And I forgot to underline here, I think. So do you know what are the topics here also in gate CS? Anyone who wants to answer? All limits and maxima minima. Maxima minima, optimization, single variable, continued differentiability. Actually, everything is there, right? Except Taylor series. You are saved by not having Taylor series. So, but see, that's the whole point, right? Only Taylor series is not there. So, if you just study Taylor series, that is enough for you to sit in the exam with this topic, because other topics I assume that you will be doing it for your gate CS, because for gate CS all these topics are important. And limit, the least I will expect you to at least know this. Few people call it hospital, few people call it hospital, whatever it is. L hospital rule, L hospital rule, whatever you call it. You must know this because it's very easy. The L hospital rule, very easy, right? You cannot use it all the time because you know the fact that it should be either a 0 by 0 form, infinity by infinity form, right? So, but if you have this limit in this form, how to calculate using L hospital rule, to differentiate the numerator, differentiate the denominator, substitute, and see if you can get a non-zero value. So L hospital rule, please feel free to learn. I think all these things you must have studied in your school as well. At least for me, it was in my class 12th exam. So I know from there. Calculus and all that, I think also you should be knowing, right? How to calculate derivatives. Integration is not there, so it's okay. You can leave integration, that's fine. Even it's not in gate CS. So, but differentiation, you should be knowing the chain rule, right? Everyone knows the chain rule, right? Chain rule, do you know? Everyone knows chain rule here? Or okay. So please also try to learn chain rule. For example, how do you differentiate sine of x square whole cube? Right? You should be able to do this differentiation by now. Okay, this is when you apply the chain rule. Okay. Okay, this is calculus and optimization. Let's go ahead. How many of you have not studied this topic? Or let me put it this way. Is there any one of you who have not studied this topic yet? I think Shruti and Vishnu, you two are here. So I am trying to ask you. Have you not studied this topic? Programming data structures and algorithms? I mean, is there anything to say that this topic is important? Should I say it out? Because if I say it out, then I'm wasting time, right? So without this topic, I'm sorry, it's very difficult to do both gate DA and gate CS. Okay, this is the least you should be able to know by now. Programming in Python, you guys are C experts, so I don't see why you would not learn Python by now. When it comes to other data structures, come on, guys. I mean, this is something that you should be covering by now. Okay, so let's. I won't waste more time here. I know you also know the importance of this topic. You should know. So, okay. So please be thorough with this topic as well. Programming data structures and algorithms. Okay. How many of you have studied DBMS? Okay, sorry, I kind of lost network. I had lost network. Sorry. Yeah. So okay, DBMS I'm studying now. ER model, functional dependency, and normalization done. Very good, very good, very good. Okay, okay, yeah. I mean, see, here's the thing. So, I have quickly covered all these topics very recently, so you can refer to those lectures where I have talked about these topics. And it's okay if you leave the other parts, okay, which are common to which are exclusive to Gate DA. See, given the time, I don't find it very fruitful to spend time on the other topics if I have not studied the more important ones. So my suggestion would be to don't actually study for the other exclusive topics if you have less time. Okay, if you have less time. Okay, ER model, functional dependencies, normalization, um, SQL, indexing. Indexing is something easy. I would suggest you guys to study indexing. Uh, right? Please study indexing. Don't leave that. Just few things like primary index, secondary index, clustered index, etc., etc. Indexing won't take more than 5 hours, guys. Come on. Okay, won't take more than 5 hours. So I won't leave indexing because it's easy. It's very easy. Okay, it's just some formula that you have to do. SQL you should know, right? SQL, I think you guys have also studied. You maybe have, if you are working somewhere, you would have used SQL there as well. So you may not fret much about it. So SQL, there is a question as well in the last year Gate DA paper. We'll do that. So there's a question as well. SQL, anyway, it's important for both CS as well as DA. So please make sure you are knowing SQL. Okay. Okay. Now this is my territory where I take part in Gate DA. I teach machine learning. If you guys have not yet seen the lectures, they are in the room. I had taken some quick lectures last year. I purposefully couldn't teach all the topics because of the time that I had. Now, the thing is, we want to strengthen that series of lectures that are there. And the idea is the topics that I have underlined are topics that I'm planning to cover in a remaining 3-4 lectures that I'm planning to take before your exam this in the next month. What about warehousing? Very good. So yeah, warehousing, that's what I said. So these the other part, right? Starting from here to here, they are warehousing concepts given the time, and it also depends on how much you have prepared. But if you have not completed the parts that are underlined, I would not go into warehousing. I would not study warehousing. Okay. In last year Gate DA paper, there were 0 questions from this topic. Okay, and even I do not find it very important to study. Personally, I wouldn't ask much questions on this if I were a examiner. But you don't know what will happen this year. No one knows that. But if I were you, I would maybe focus more on the more important topics that I have underlined above. Again, if you have time, feel free to study. But if I were you, I wouldn't actually venture into this territory. So this is about DBMS and warehousing. Now let's come back to machine learning. There are few topics that I have not taught very well, or in for that matter, I didn't even touch this topic called linear discriminant analysis. And the idea is to teach you this topic for the remaining 3-4 lectures. Again, these lectures are optional. I do not want people to waste their last month time. If you feel that are you are better able to manage time by practicing on your own learning, you can anyway do that. No one has forced you to join these lectures. You can anyway watch the recordings later on, because to watch LDA, to understand LDA, you need to understand these things. Okay, so my plan is to cover LDA. If no one is there in the class, I will just record it so that later on people can watch it. That's what I did last year, because I know if I were a student, I would also join thinking whether I should. Okay, so anyway, so but if you join again, I will give you the format of these lectures, how it can be beneficial to you in some time. Okay, so LDA is something that I will cover. Okay, in the lectures that are planned later on next week. And unsupervised learning is something that I had talked in a very fast manner in my course earlier in the last year. So the idea is to teach you unsupervised learning. It's a very easy topic. I will highly suggest you to attend these lectures that I will take, because you will actually learn. If you learn this topic right, there is guarantee 5 marks free for you. Okay, I will suggest you to please attend these lectures. Again, it's a choice, but if you attend these lectures, I can guarantee you, you will go out learning something. Okay, if you learn this part, very very beneficial for your exam, because last year also there was a question asked from k means, from bottom up clustering hierarchical, from PCA as well. Okay, so it's important. So these are the topics that I will cover. Other topics are already available, I don't want to repeat things. Okay, and if you watch my lectures that I have taught last year, I have actually explained things in a faster manner because of the time was very less, right? So I'd explained all these things in the lectures. So I will suggest you to kindly go through those lectures. The most important topic for your exam is this, the one I have bracketed. Okay, bias variance trade-off. Uh, there can be like infinite number of MCQs asked from this topic only. So you should know this. Cross validation methods like leave one out and k-fold, these are easy, very easy. These are just techniques to do cross validation. So it won't take more than half a day to cover this part, cross validation, and this part. It's very simple. Okay, LDA is difficult. Okay, let me tell you, LDA is difficult. I am not kidding, and I don't want to sugarcoat here. LDA is difficult, but still, it's something that if you understand, it's good. I expect this is not a very important topic, but to for completeness, I am trying to cover. Unsupervised learning is something that I'm planning to cover in a very great depth in the lectures that have been planned. Okay, so this is about machine learning. And now comes your, not my favorite, but maybe your favorite, AI. AI is another topic that is there. Not many questions have been asked from AI in the previous year. Uh, I don't know if you were able to see the slide because I can't myself. So maybe you should wait. I started speaking before the slide came up. So, okay. So, okay, we'll wait. Anyways, so this was about ML, right? ML is, I mean, see, probability stats is one of the prerequisites for ML. But if you see my lectures that I have given, I think I have explained things without having the assumption that you should know probability stats. When at times I have also taught you some probability stats as well. So please check out those lectures. It will help you in your exam. You may watch it in 1.5x, 2x. The idea is to understand things rather than watching them in a particular speed. Okay, so this is about ML. Now the next slide is not loading for me. You guys cannot see the next slide, right? Or can you see? I'm not able to see it. We can see. Oh, okay. 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 Now I can see. Right. I'm able to see. You're able to see. Maybe. Okay. Anyways, so yeah. So AI has this topic: search, informed search, uninformed search. adversarial search. You know, there is one topic which is common with your discrete maths here: logic, propositional logic, predicate logic. Okay, these are the topics that are there in your gate CS as well. And there has been a question asked from this topic as well. We'll do today only. There has been a question asked from this topic as well. Okay, apart from that, again, if I don't like this topic, that's why I won't study. Okay, let me be honest. Okay, if I don't like these topics, I tried to study once, it was boring for me. I didn't even go into much depth on it. But again, you can do your judgment in this topic. I am not the right person to even talk about it as well. um, but again, if you learn these three topics, these are there in your GATE CS syllabus as well. So this is about AI, and this was the weightage in 2024. I have sorted this data based on marks. Okay, so you can see which is the most important topic, right? I think it's clear by now. It is data structures and algorithms. Data structures, algorithms, and your general aptitude. If you these two topics carry in total 36 marks, right? And probability and stats is about 16. Second most important topic. See, aptitude is anyway 15 marks, right? It should be 15. It's always the gate exam is like that. 15 marks of aptitude, rest 85 marks is your core paper. So, and also machine learning is 11 marks, AI is 11 marks, linear algebra is 10 marks, calculus is 8, and database is 8 marks. Okay, so you can refer to this data to decide better which subject do you want do you want to focus on more. But again, if you learn data structures and algorithms, even for gate CS, I think this is the most important topic, and you can also see the pattern is same for gate DA as well. Okay, any questions before I start with the question, before I start with the small problem solving session, gate CS questions that were asked last year in gate DA paper? Any questions before I start? No. So the format of these lectures are very simple. The theory lectures that I'm trying to take of ML, I respect time of people. So what I'm planning to do is like this. Every class I will cover theory 1 hour. Okay, I will cover theory 1 hour, and the next 1 hour we will solve problems. Not on the theory that I have taught, but on other topics that I find more important. For example, there could be a gate CS question, there could be a gate DA question. We'll solve questions, we'll learn through solving questions, and that is how I'm planning to approach these lectures. Even if you don't plan to stay for the theory, you think you can learn it later, that's fine. I will highly suggest you to start to attend the problem solving sessions, which will be done at every day 9:50 p.m. for a 8:50 class, or 11 a.m. for a 10 a.m. class. So 1 hour will cover theory, and then we'll go with the problems. Problems could be either gate CS, gate DA. Now for problems, either you can tell me to take it as a quiz, or you can tell me to take it as a solve along. For example, I will give you some time to solve, and then I will solve the question, teach you the underlying concept. Whichever you want, I can do that. Okay, you can also take it as a mock test, whichever you find useful. Again, if these lectures are also not very important to you, you can say that as well. I will also release a poll in the WhatsApp group in tonight, in some time, where I will take some votes from people if they want these sessions. You guys are actually the boss now, because you guys are appearing for the exam, not me. So feel maybe you can use that poll to let me know if you are interested. Okay, so these are about the things that I'm planning to cover. Okay, so without any further ado, let's start with the some Gate CS questions that were asked last year in the Gate DA paper. Do you guys want to take some time to solve these questions? Okay, I'll give you some 3-4 minutes to solve each question. Take your time, but anyway, if you are not able to solve, you will learn something. If you are able to solve, good. So in either way, you are not losing anything. So one hint I can give you to this question is if you try to do DFS or BFS on a graph, um, try to find what is the output you get. There is a question very common in Gate CS where they tell you that what are the sequence of vertices that you visit starting from a vertex U using BFS. And there is always a particular sequence you will visit the vertices. For example, first you will visit the neighbors of U. I'm talking about breadth first search BFS. Then you go to the one of the neighbor, you visit its neighbors. So it's always a pattern. So what is this structure called? If you know this, you will be able to answer. I was surprised to see this question here because it's a theoretical question. Okay, if it's there, it's there. Another hint. Can you tell me whether you will visit V before U or will you visit V after you visit U starting from S if you run a DFS? Understood? If you run a DFS from S, will you first visit V or will you first visit U? What do you think? Starting from S, if you do a depth first search, will you first visit U or will you first visit V? Why? You are correct, Shruti, but why? Why do you think it will be visited first? Oh, so you have answered it. So what is the answer then? Good, that's the answer. But okay. So for others, you will start from S, then you will visit the neighbor U, then either you go to A or to V, that's fine. Let's say you go to A, you come back, then you go to V. Because U is closer to S, you will visit U first from S and then you will go to V. Because the distance of U is less than the distance of V. That's what the question is saying. I just gave you an example. Now, why is it called a tree? Because let's say that there was an edge connected like this. Is this a tree? Is this graph a tree? How to check if this graph is a tree? A tree should be number one, a connected graph, and the second, the number of edges should be number of vertices minus 1. Is the number of edges equal to number of vertices minus 1? No. Right? Number of edges is 4, number of vertices is 4. It is not a tree. But if you do DFS, what happens is, let's say the nodes that you are visiting, they form a tree. Let's say. So you start from S, then you go to U, then you go to A. Okay? Then you may go to V. Your DFS is over, right? You would not visit U again, right? Because you have already visited U. Or you can either go to U, you can go to V, then you can go to A. So all these diagrams that I'm trying to draw are ways that DFS would traverse this graph, and they are nothing but all trees. Okay, they are nothing but trees. So it's nothing but a tree edge. Okay, so this was one of the questions that was asked. This is the next question. Very easy. Come on, if you are not able to answer this, then I need an answer from every person on this question. Others, Mohammed, Vishnu, shouldn't take so long. A stack works on which principle? Last in, first out, or first in, first out? Shruti, a stack works on which principle? So if you just match this, all the other options are gone. Okay. And obviously queue works on first in first out, and the whole point of using a hash table is to do something called lookup operation, which is very fast for a hash table. So that's why option A is the right answer. I mean, this is question that is like free marks for a CS student, but as I said, other branches also appear for this exam, so for them it may not be as easy as it looks for you. Okay. Question from relational algebra. Okay, so the correct answer is option C. Good. So, do you remember what is this pi? Pi is the projection operation where you just retrieve some columns from your database. So, from the forward table, you are retrieving the names of the people who are forward. From the defender table, you are retrieving the names who are defenders. Now, if you retrieve the name from the team, all the members from the team, if you subtract this set, which is the number of defenders and forwards, if that is empty, right, that will be the right answer. Okay. Okay. It will give you uh, the people who are at least not who are either a defender or a forward. Okay. No. So what B will do is, for example, if there are names who are not defender, if there are names who are not forward, right? Then this intersection will select those will be a null set. Okay. Okay. This intersection will be a null set. Intersection is like who the people who are both defender as well as forward. What are the names who are both defender and forward? That is not what they are asking. Okay. But good attempt. Okay. Next question is this. Please read the question very carefully before you try to answer. Please read very carefully. Okay, let me repeat. Please read the question before you answer. Is given is or are. It's an MSQ. Yeah, so there are three things that you have to look at here. First is they are saying binary tree. They are not saying, okay, everyone knows the difference between binary tree and binary search tree, right? Everyone knows it, right? In a BST, if there is a node with a value v, the left subtree will contain all nodes with value less than v, while the right subtree will contain all nodes with value greater than or equal to v. This is for binary search tree. For a binary tree, it could be anything. It could be 5, 6, 4. This is a binary tree. Okay, but this is not a BST. For a BST, this is a BST. Okay. Now, if you have any of a pair, pre-order, in order, post-order, pre-order, post-order, you will be able to uniquely construct a full binary tree. Option A, option B, option C are correct. Now, let's say this question was asking BST. Will the answer change? Will the answer change? Let me give you a hint. If you have a BST, can you tell me what does the in order give you as the output? For any BST, no, in order is left root, right? That's fine. L plus R. But what is the output? The nature, the nature of the output. The output is always what? Always dash for a BST. If you take an in order of a BST, the output is always in sorted order. Please keep this in mind. Okay. Okay. The for a BST, the in order will always be in sorted order, the output. So if I give you a pre-order, let's say I give you a pre-order, some set of values I give you in an array. If you sort this array, what do you get? You get the in order. Now, pre-order, in order you will be able to uniquely construct the tree. Understood? Understood? This is true for a BST. Also, if you have a post order, some set of values in an array, you may again sort it. You will get the in order. Now, once you have the in order, you can uniquely construct a tree. Similarly, if you have the pre-order, if you have the post order, you may sort any of them, you will get the in order. Then, though you have all the three things, you will get a unique tree. This is for a BST. Okay, clear? Yeah. Yes, Mohammed. So, in order goes. So, you're talking about a BST, right? So, if you have any of them, for example, okay, let's not talk in just like that. Let's take a real BST and show you. So, I have 5, I have 4, I have 3, I have 2, I have 6. Sorry, I need to have 7 here. I have 6, I have 8. This is not a BST, right? Because there is a problem here. I will fix it. 3, 2, 4. This is a BST, right? Everyone agrees this is a BST? Can you tell me what is a pre-order? Anyone? What is a pre-order? What is the rule of pre-order? You first process the root, then you go left, then you go right. So you first process the root, then you go left, then you process the root, then you go left, you process the root, then you don't have any way to go left, you don't have any way to go right. So you again come here, process this, go to the right, process this, come here, go to the left, process it, go to the right, process it. This will be a pre-order. Everyone knows this? Everyone knows this, right? No one here who says no. Okay. So what is the in order? You may calculate it two ways. One way is you can sort it 2, 3, 4, 5, 6, 7, 8. You can also do the in order traversal. You will get the same output. Okay. What is the post order? Yes. What is the post order? So you go left, there is a subtree, you go left, so left, right, root. You go right, there's a subtree, left, right, root. Yeah, that's the algorithm, but what is the post order? This is the post order, right? So let's say you were only given, you calculated the pre-order. Now, if you know the pre-order, you can sort the array, get the in order. Okay. Now, let's try to see if we can draw this tree back or not. Okay. In a pre-order, the first you process the root. So we know that 5 is the root of the tree. Okay. Now you mark 5 in the in order. Now in your left subtree, you will contain the values 2, 3, 4. In your right subtree will contain the values 6, 7, 8. Okay. Now let's process the left subtree first. Look at the pre-order. First you are process 3. That means in the left subtree the root is 3. Now you mark it in the in order. You see 2 is written on the left, 4 is written on the right. So 2 is written on the left, 4 is written on the right. Then you mark 2, you mark 4 because you have done all this. Then on the right subtree, first you processed 7, which means 7 is the root of the tree. So yeah, which means 7 is the root of the tree. Now you mark it in the in order. The left contains 6, right contains 8. Left contains 6, right contains 8. You get the same tree back. Okay, this is how you can draw the tree back. Okay, so this is the question, an important question for your gate CS as well as gate DA paper. It was asked in gate DA last year, so I hope it is clear. Now let's go to the next one. Minimum number of swaps performed using quicksort is what? Yeah, every one of you are answering correct. 0. Okay. So first thing is the array is in, you're trying to sort in ascending order. The array is already in ascending order. Okay. If the array is already in ascending order, you're trying to sort in ascending order, you will actually not do any swap. So it is 0. Okay. Okay. Let's flip things a bit. Let's say you're trying to sort in descending order. How many swaps will you do? How many swaps will you do? So first you will have to bring this 100, which is the last element of the pivot, to the first position. So that will be uh, 1, 2, 3, 4, 4 swaps. Now the array will look like this. Okay, then you will take this 90, bring it here. So 1, 2, 3, 3 swaps. Okay, so 100, 90, 60, 70, 80. Then you will take this 80, bring it with 2 swaps. Okay, so 100, 90, 80, 60, 70. Finally, you will take this 70, swap it with 60. In total, you require 10 swaps. Okay, this if you do quick sort. Okay. This is a question from your discrete math. Very simple question. Please try this out. How did you solve, Vishnu? Truth table or laws? Truth table. Okay, good, good. Okay, so if I were you, how would I solve this? Is first I will write. So truth table is one of a good way to solve. Okay, it's a very good way to solve. You will make a very less mistake. But truth table is also easy to solve. So I'm not actually telling you how to solve by truth table. But let's also use the laws, because that's sometimes also important when you have bigger expressions. In this case, there is only two variables, so truth table is a better way to do it. But also, if you want to use the laws, how would you do so? So first of all, we know that x arrow y is not x or y, right? We know this. So if I open this arrow, I will write this as not of x and y, or I can also open this not of y or x. y arrow x, I can open it like this. Now there is a not, you want to bring it inside an and, you apply something called the De Morgan law, which becomes, so not of x becomes x, or not y, or not y, or x. So if you solve, you will get x or not y. Now it's very clear that there is always a combination where it will become false. In essence, if the value of x is true, sorry, if the value of x is false, value of y is true. If this is the combination, then x or not y will be false. So that's why it's not a tautology. So option A is not a tautology. Similarly, I will do for the next one. So x and not y, arrow not x, arrow y. Okay. Again, I would open the arrows. I would simplify things with just and not. And so I write it as not of x or y. So I place a not here and then applied De Morgan law to get this, or x or y. Now, whenever you see terms with only or, okay, and if you see x and a not x, or a y and a not y, if you see this, it is definitely a tautology. Why? Because not x arrow x, sorry, not x or x is always true. True or anything is always true. Okay, this is one of the tricks. So option D is one of the answer. Now go moving to the next one. It is not x and y, arrow not x, arrow y. Okay, so if you open the arrow first, you get x or not y, or not x, sorry, then you open this arrow first, so not of not x becomes x or y. Now you have not y or y, that is enough to say this will be a tautology. C is also a tautology. Finally, x and not y, arrow y, arrow x. Again, I will open the arrows, so I get not x or y, or not y or x. Now this has y not y, x not x, and everything is a disjunction. So this will be a true as well. So B, C, D are the right answer. You can use any method you want. If I were you in the exam, I would use a truth table because I would make less mistakes, right? But since I also have to show the other part as well, this is also one of the good ways to do this question. Okay. Okay. I think this is the last question. This is on SQL. Okay, so first thing you do is you always try to follow the where clause. So city is Jaipur. So first thing you do is you remove everything that is not Jaipur. So you remove Patna, Hyderabad, these rows. You remove these rows, right? And the red points is greater than 200. That eliminates the first row. Sorry, that's a bit points. Sorry. Red points is greater than 200. So it removes these rows. That's it. Okay. Now you join based on radar.id with the team.id. So wherever radar.id, so first the radar ID is 1. Is there a team ID 1? There is. So this is one of the rows returned. So this is one of the rows returned. We have a radar ID 2. Is there a team ID 2? Yes, there is. So this row will also be returned. We have a radar ID 5. Is there a radar ID 5? No. So not returned, not returned. So there are two rows returned. Why 3? Is there any row that I missed? I might be wrong. I don't know. Have I missed any row? Last row is Jaipur. Oh, sorry. Why did I remove it? It's something else. Sorry, sorry. Yeah, correct. So this will also be returned because there is this person Gopal, reader ID is 6, team ID is 6. So in total, 3 rows are sorry. Okay, uh, good. You understood it. Okay, so this was some basically the questions that I discussed. Again, the format of these lectures. Let me again reiterate. Um, the format of these lectures are to teach you 1 hour theory on Gate DA and 1 hour problem solving sessions. Okay. If you only want to attend the problem solving, you may join after 1 hour. Okay. There is no compulsion to attend these lectures because I know that you guys are busy with your preparation, but also the thing is these lectures are fruitful for you at this time because you will get to learn something new here, and we will solve some questions. The questions will not be based on the theory I taught you. It will be based on generic CS questions. It could be gate CS as well. It could be gate D as well. But certainly not of the theory that I will teach. So problem solving we'll do for 1 hour. Theory we'll do for 1 hour. And in the next class, what we'll do is we'll do unsupervised learning. And also, if you have any doubts, feel free to ask me on WhatsApp. If there is any concept, any question that you want me to cover in the next class, you may say so. In that case, this theory, I will try to accommodate the doubt that you have. Okay. So again, these lectures are optional for you. Let me be very clear. Okay. No one is gonna kick you if you don't. So, but my suggestion is to attend these lectures because these are useful for you to learn and revise for your last phase of preparation. And especially if you attend the problem solvings like we did today, I'm sure that you will actually learn something. Okay. Any questions before I end the class? All subs, sir? I didn't understand. All subjects you're saying? No. So the subjects that I taught. See, I'm not good in all subjects. Okay. For example, if you have studied computer networks, that is a subject that is a nightmare to me. Okay. I run away from that subject as far as I can. For example, there is a subject you might have studied called. No. The same here nahi hoga, sir. See, for CN, don't say same here, okay? Because I know it's difficult. I was a student as well, but please do not go to the exam without knowing this topic, IP addressing. Okay, IP addressing. I will suggest you to please study this topic. and also study the topic of TCP/IP handshaking and all that. Yeah, TCP. You have to. There is no option, right? And these two are topics that you must study. This IP addressing includes the classful and classless addressing. Again, when I'm speaking, I'm kind of getting afraid because I was not very good in CN, but that's what it is. Okay. So classful, classless addressing, you should know this. Yeah, for me it was difficult because of the amount of topics that are there in the syllabus. It's just too high, too much to grasp, and also questions can be just like anything they can ask, right? They ask questions on flow control, congestion control, error control, and you guys know better, right? And also there are some like headers you have to learn. TCP header, if I remember, I don't remember now. There's an HTTP header, there's a UDP header, right? If you guys can relate, TCP header, UDP header, um, all that, I mean, you have to anyway. If you study these things, then they are good. But CN is a subject that I was very afraid of. CN was one of my difficult subjects. I will ask you questions on um, uh, either you can tell me the topic maybe 2 days before the lecture. That way I can prepare that way on that topic. Otherwise, I will ask you questions on C, DSA. There will be questions on COA, compilers, POC, discrete maths. Okay. And also maybe, I am not very sure, maybe I will also ask on digital logic, DL. Okay. Any questions before I end the class? Any other questions before I end the class? For ML, till where can you cover before the next class? Okay. In the next class, you need not study anything. Okay. Unsupervised learning is a topic that is full from scratch. Okay. Okay. So full from scratch. I'll start from the very beginning of unsupervised learning. Okay. Anything else? If you need to know a few things that were there in your so you know this, right? If there are 2 points, 1 comma 2, 3 comma 4, what is the distance between these 2 points? You know the formula. Distance between 2 points, Euclidean distance, Euclidean norm. You know this, right? I mean, this was there in your syllabus in your school. It's like root over x2 minus x1 whole square plus y2 minus y1 whole square, right? You know this, right? This is not something that is new, I guess. So this is uh, root over 4 plus 4. This is root over 8, whatever is the answer. 2 root 2 and 2 into 1.14, 2.82 something. So this is something that if you know, you should be good with unsupervised learning. Okay. Anything else? Others, Vishnu, Mohammed, anything you want to ask? Sorry, enabled the download button. I wanted to send it on the chat. Has it not been shared already by the team? Shruti, have you not received any set of questions from the team? Oh man, I spent a whole night to create questions for you guys and you have not received it. Okay. Anyway, I'm sharing it here. I don't know why. What was the? I'll ask the team also why they didn't share. It's something surprising. Okay, I'm sharing the questions here. These are some questions that I created on my own. Some are from the internet, some I created. These are very important questions that are there in your uh, exam. No, I think it was not shared, but I kind of am very sad because I spent a night to write these questions. Anyways, it's okay. Now you have it. So these are questions from every topic that I have made. You can see. Please, these are questions that are the most important according to me. 100 questions are there per topic. Some are from the internet, some I created when I was a student. So I used to have them as notes. I just added them here. So you can refer to this also as your references. Okay, there are keys as well, like solutions as well. If you have any question, if you have any doubt in any of these questions, you can let me know, and then we will discuss it in the class. Okay. Yeah, it's only ML because I only teach ML for KDA. Others, I am not very much idea of the subject itself, so I'm not the right person to give you questions on the same. But since I teach ML, so I created questions on ML. Others are like CS subjects. You can anyway get it. I think the team has would have already shared you um, the CS questions, CS subject questions. I think. Uh, yeah, good. Anyways, okay. See you guys next week. Prepare well and mm, hope you do well. So these lectures are also designed to help you to uh, make sure you are. I am there for any questions, and also I am there. If I will solve along with you so that you get to learn in the last moment things uh, that you will learn. Okay, and let me quit the recording before I start saying.